All right. Today we're going to be looking at 5.2, which is polynomial division and division algorithms. So a lot of algebra-based stuff in this one. All right. So again, this will be lesson 5.2, polynomial division and division algorithm. All right, so there's just a couple of things just to note on notation purposes. So a few notes here. You're going to see things that look like this within your notes, the learn it part, the directions, the homework. I just want to make sure that you understand what each part means. So this will say P of X is equal to Q of X times D of X plus R of X. Now, these aren't just random letters. They all have a purpose. This right here is called the dividend. When dividing, this is typically what number's in the numerator, the top number. This is the quotient. This is typically our answer that we would get after dividing. This is our divisor. So this is typically the denominator of that fraction. So typically you would have the dividend divided by the divisor and it'll equal the quotient. And this part here is going to represent our remainder because not everything's going to go divide evenly. So again, to kind of rewrite this in a format that you'll be seeing a lot, is you have your P of X divided by your D of X, and that will equal your Q of X plus your R of X divided by D of X. So if we do have a remainder, we'll write out the answer plus remainder divided by whatever we were dividing by. Another note is if C is a 0, so a random number, if it's a 0, then X minus C is a factor. So if I tell you in this directions here that, hey, 2 is a 0, then I know X minus 2 is a factor. Another thing we're going to look at today is the remainder theorem. And this is basically just stating, well, if I have a P of X and it can be written as my quotient times X minus C, which is that factor, plus P of C, then my P of C would equal my remainder. What that basically means is if Z is a value that can be written like this, then I can use what we're going to call synthetic division. So we'll learn two things today: long division and synthetic division. When I teach you synthetic division, we're going to be able to use this to determine, hey, what's just the remainder? Like if I just want to know what the remainder is and I don't care about anything else, and I say, hey, what's the remainder if C is equal to this value? I'll be able to quickly do the synthetic division and say, hey, the remainder is this. I can also use synthetic division to get the quotient along with long division. So I'm going to show you both techniques because you have to do both techniques. All right, so that's pretty much all of the notes that are in 5.2. So as always, I want to jump right into questions that look like your practice. And then, of course, if you ever need more examples, please reach out and I will give you some more. So the first example we're going to look at is number 2. We are given 5x squared plus 9x minus 6 divided by x plus 2. And we were asked to write it in that format. Let me just go back. We're asked to write it in this format here, and I'll show you how that can work out. But it says by using long division. So here we go. So long division, if you remember back in grade school, the numerator would go in the house. So that'd be 5x squared plus 9x minus 6, and then the denominator would stay outside of the house. And then you would figure out how many times this this number go into this, and then you would do some subtracting, figure out what you have left, bring down the next number, and then ask yourself the same question. Almost the same process, except we're going to look at the first terms. So we're going to look at x and 5x squared, and then we'll keep that pattern going. So what I'm going to do first is I'm going to divide first. So 5x squared divided by x gives me 5x. So again, step one, divide. So that's going to be 5x squared divided by x, which gave me 5x. Notice I wrote the 5x above the 9x. Just like in grade school, we try to keep our values in their correct like category, like the tens place, the hundred place, the thousands place. Same concept. I want to line up my like terms. So once I get this value, if you recall in grade school, we then took that value, we would multiply it back out and see what that number is. So in this case, step two, now multiply. So I'm going to do 5x times x, and I get 5x squared. 5x times 2, because I have to do it to the entire thing, would give me 10x, a positive 10x. And if you recall, the next thing we did is subtract. So what that does is this now becomes a negative 5x and a negative 10. So this becomes 5x squared minus 5x will just go away. Then I get 9x minus 10x, and that would give me negative 1x. And then we would drop down the next thing. Now you repeat the pattern. I'm going to divide negative x by x, and I get negative 1. Again, lining up with my terms. So this is my constant terms. And then now I'm going to multiply. So negative 1 times x gives me negative x. And then negative 1 times 2 gives me negative 2. Now I'm going to subtract. Negative x minus a negative x will produce a positive x, which will cancel these out, which is the whole point. Then this one is negative 6 minus a negative will become a positive. So negative 6 plus 2 gives me negative 4. This guy is what we call the remainder. And so the way we write it is we'll say plus or minus. In this case, I'll write minus. You write the remainder, and then you write your divisor, which in this case is x plus 2. So this is your q of x right here. This is your r of x, and this right here is your d of x. So there's your answer right there. And that's kind of how they want it. And then that'd be it. All right, so hopefully that wasn't too bad. So make sure that doesn't look like an equal sign, but let's do another one to make sure you understand it. We'll do a couple actually. I don't expect you to know it right off the bat, but hopefully you see it. So we'll look at example 6 this time. This one says x cubed plus 2x squared minus 4x minus 8 divided by x minus 3. Same process, okay? I'm going to take the numerator. It's going to go in the house. So x cubed plus 2x squared minus 4x minus 8. Take the divisor or the denominator, and it stays on the outside. And I'm going to repeat the 3 steps. Step 1, divide. X cubed divided by x gives me x squared. Step 2, multiply. X squared times x, x cubed. X squared times negative 3, negative 3x squared. Again, pay attention that I'm lining up my like terms. Step 3, subtract. X cubed minus x cubed goes away. 2x squared minus a negative 3x squared makes that a positive. So this is really 2x squared plus 3x squared gives me a 5x squared. Drop down your results or the remaining of your function. Now, step 1. 5x squared divided by x. That would give me 5x, a positive 5x. So now I go 5x times x gives me 5x squared. 5x times negative 3 gives me negative 15x. Step 3, subtract. 5x squared minus 5x squared goes away. Negative 4x minus negative 15x, that makes it a positive 15x. So really this is negative 4 plus 15. So that would give me 11x. Drop down the rest of the function and repeat. Basically, you keep repeating until you can't go no more. So 11x divided by x. So that would give me positive 11. 11 times x gives me 11x. 11 times negative 3 gives me negative 33. Subtract 11x minus 11x. That cancels. Negative 8 minus negative 33 would basically make that a positive 33. So negative 8 plus 33 is 25. Again, that is my remainder. So I'll say plus 25 divided by x minus 3. Right? And again, you just keep repeating that process until you just can't go anymore. All right, so let's do one more in long division, and I'll feel pretty confident that I've given you enough examples. So let's look at number 13. This says 9x cubed plus 2x divided by 3x minus 5. All right. Now, one thing I need to note here, the two previous questions could have been solved using synthetic division when I teach you. This cannot. A synthetic division can only be worked if it's written as x minus c. Notice I now have a number x minus c. So long division will have to be done. So it is good to know both ways because synthetic division only works for some. If you're familiar with synthetic, if you're not familiar, you might be going, I still don't know what that is, which is fine. I'll explain when we get to that point. All right, slightly written differently. A couple things I want to point out here. The numerator still goes in the house, but notice it has some missing terms. You want to fill those terms in just like you would if you had the number like, I don't know, let's say 1030, right? You wouldn't just write 13. You would write 1 for the thousands, 0 for the hundreds, 3 for the tens, 0 for the ones. You want to do the same thing for every term. So this would be 9x cubed. I have no square, so I'm going to say plus 0x squared plus 2x. I have no constant, so I'll say plus 0. So now I have a placeholder for every term, just like you would if you had just a 4-digit number. And then you would do the same thing on the numerator if you had that situation, but I'm not missing any terms. And now we're ready to go through the process. So it's more than just an x. We have a little bit more, but it doesn't change. Step 1, divide. 9x cubed divided by 3x is 3x squared. Now notice also I was able to have somewhere to line up my terms. That's another purpose of that. It's also a purpose so that we don't mess up our math, but this also helps line your stuff up. Step 2, multiply. 3x squared times 3x is 9x cubed. 3x squared times negative 15, negative 15x squared. Second step, subtract. 9x cubed minus 9x cubed, 0. 0 minus negative 15 is the same thing as 0 plus 15, so this gives me 15x squared. Drop down the rest of the function. Yes, I'm going to write the 0 so I don't lose it. And repeat. 15x squared divided by 3x. All right, that would give me a positive 5x. Step 2, multiply. 5x times 3x gives you 15x squared. 5x times negative 5 gives you negative 25x. Step 3, subtract. 15x squared minus 15x squared, 0. 2x minus negative 25x is like 2x plus 25. So that gives you 27x. Drop down the plus 0. And repeat. 27x divided by 3. X would be 9. 9 times 3x is 27x. 9 times negative 5 is negative 45. Step 3, subtract. 27x minus 27x is 0. 0 minus negative 45, that's like a plus 45. And remember, that is my remainder. So I'll write it as plus 45 over 3x minus 5. there is your final answer. All right. All right. So hopefully you have 3 good examples, nothing that will come out looking strange or anything on the homework or anything that you didn't just see. But if there is more examples, you're like, okay, we didn't see one like this. Can you show this one? I will definitely do that. All right. So let's kind of move on to the next type of questions you'll get. So let's look at example 21. Now, in these examples here, you're just asked to use synthetic division to determine if the given value for C is a 0 of the corresponding polynomial. If not, determine P of C. Is that just wanting like the answer? Hold on. Oh, yeah, gotcha. Okay. So it's the same process. So I'll show you what happens when it's not a 0, what the answer is. All right, so synthetic division works in this sense. So let's look at 21. So P of X is equal to 32 x to the 5th minus 80 x to the 4th plus 80 x to the 3rd minus 40 x to the 2nd plus 10x plus 2, and your asked is C equal 1 a 0. So this is how it works. You put the C value in what I like to call a window, so like a little box around it. Now, what I'm going to do next is write all of the numbers for each coefficient, or for each degree, I guess. So I want to write all the coefficients for each degree. So for x to the 5th, that's going to be 32. For x to the 4th, that's going to be negative 80. Notice the sign went with it. For x to the 3rd, that's going to be positive 80. For x to the 2nd, that's going to be negative 40. For x, that's going to be positive 10. For my constant, which I'll call C, will be 2. Now, if I would have been missing any of these degrees, I would need to still write it and put a 0 just like long division. All right, now this one only has 2 steps. You start off by dropping the first number. So I drop the first number. This gets the party going. Step 1, multiply. 1 times 32 is 32. Step 2, add. Negative 80 plus 32. Hold on. What's that, like 48? You don't want to mess up on these parts because it will throw you off. So 80 minus 32, yeah, 48. Okay, so this gives you a negative 48. Then you repeat. So 1 times negative 48, negative 48. 80 minus 48. And then you get 32. Then you repeat. 1 times 32, 32. Now add. Negative 40 plus 32 is negative 8. 1 times negative 8, negative 8. 10 plus negative 8 is 2. 1 times 2 is 2. 2 plus 2 is 4. This right here is your remainder, and that is your answer. So what happens here is your conclusion is that C equals 1, not a 0. If it would have been a 0, you would have got 0 as a remainder because that means it would have factored into that polynomial. The second part of the question goes, if it's not, what is P of 1? That will be the answer to whatever the remainder is. So you don't have to do like an extra step. If it's a 0, it's a factor. If it's not a 0, then P of 1 would equal 4. Right? And that's it. So let's do some more. So let's look at example 23. This one says P of X equals 12x to the 4th minus 7x to the 3rd minus 32x squared minus 7x plus 6, and you're trying to determine if C equals 2 is a 0. So here we go. 2 goes in the window. My coefficient for x to the 4th is a 12. My coefficient for x to the 3rd is negative 7. My coefficient for x to the second is negative 32. My coefficient for x is a negative 7, and my constant is a 6. Now I'm ready to rock and roll. 2 times 12, 24. 24 minus 7, 24 minus 17. 2 times 27, 34. Negative 32 plus 34 is 2. 2 times 2 is 4. Negative 7 plus 4, negative 3. 2 times negative 3, negative 6. 6 plus negative 6, 0. This means C equals 2 is a 0 or a factor, however they want you to answer that. All right. There you go. And that's it. And if it wasn't, then that would have been the answer as well. Let's do one more before I move on. Let's jump down to example 31. So P of x is equal to 2x squared minus 3 minus 5i x plus 3 minus 9i. And we're just trying to determine, is negative 3i a 0? Remember, imaginary numbers can be solutions. We just don't see them on a real plane. You'd have to graph it on an imaginary plane, which is a whole different conversation. All right, so here we go. So negative 3i goes in the window. And now I'm going to write the coefficients. These are technically coefficients. What I mean by that is my coefficient for x squared is 2. My coefficient for x is negative 3 minus 5i. All right, so that whole thing is a coefficient. And then my constant would be 3 minus 9i. So we have a little bit more work to do, which is not going to be as quick as what we were. Process does not change. You just got more to do. Drop down the 2. I will say in my past experience, most students make a mistake right here at the very first step. They forget to drop down the first number, then start multiplying. And what typically happens is they'll just do negative 3i times 2, write that result there, and then move on, and you'll be one number off, which will cause the entire problem to be wrong. So you want to make sure you drop down the first number and then start the multiplication adding process. So here we go. Negative 3i times 2, easy. Negative 6i. Here's where it's not so easy. So I'm going to do some side work. I'm going to go ahead and distribute that negative. So that's going to be negative 3 plus 5i plus negative 6i, which in case is minus. So that'd give me negative 3 minus I. So that would be my result right here. Negative 3 minus I. Now I'm going to take that negative 3i and I'm going to multiply it to my negative 3i. So that's negative 3i times negative 3 minus I. So I'll distribute. Negative 3i times negative 3 is a positive 9i. Negative 3i times negative I gives me a positive 3i squared. In an earlier video, I said that I squared is equal to negative 1. So this is 9i plus 3 times negative 1, which just gives me negative 3 plus 9i. So I'm going to take that, and that's going to be the result. It goes right here. So negative 3 plus 9i. Now I add. Well, 3 plus negative 3 will cancel. Negative 9i plus 9i will cancel, so I'll have nothing left. So that tells me that negative 3i is a 0. So it is a factor, or it can become a factor. All right. So even though we have i's, the process didn't change. We just had a little bit more work to do to show what each step would be. All right. So hopefully that kind of helps with any confusion when you see that one. All right, let's jump into a couple more different type of questions you'll see, and then we'll pretty much be done for today. So let's look at example 46. 46, you're asked to use synthetic division to write the answer. So beforehand, we were just looking at the remainder. That would have been the answer. However, there is that all those other numbers give us more information, and I'll explain on this part here. So here we go. So on example 46, we have x to the 6th minus 2x to the 5th plus 2x to the 4th plus 4x to the 2nd minus 8x plus 8, all divided by x minus 1 plus I. So I told you beforehand to use synthetic division. So, little note here. To use synthetic division, the divisor must be in the form of x minus c. So meaning x minus some 0. So what happens is you might go, well, this is 3 terms. It's not. Negative 1 plus I is its singular number. So what we do is, as a side note here, we would say x minus 1 plus I equals 0. So that means if I was to add the 1 and subtract the I would equal 1 minus I. That is your 0. That's like that the C value that we were given earlier. So that 1 minus I is what will go in the window. So notice this doesn't go in the window. You have to set equal to 0 to find that C. That goes in the window. Now I can write all of my coefficients. So the coefficient for x to the 6th is a 1. If there's no number there, it's imaginary 1. If there's no term there, then it's a 0. X to the 5th would be a negative 2. X to the 4th would be a positive 2. X to the 3rd is not there. So again, that's why we write it out like we do. That would be a 0. X to the 2nd would be a 4. Let me make sure I didn't miss. Okay, there was one there. And then my x is a negative 8 and my constant is an 8. Now I'm ready to start the process. So remember, the first step is to drop down that first number and then get the party going. So 1 minus I times 1 is 1 minus I. Negative 2 plus this, I can only combine these like terms. So negative 2 plus 1 would give me a negative 1 minus I. So when I work this out, I'm going to have to do some side work over here. I'm going to do 1 minus I times negative 1 minus I. So 1 times negative 1, negative 1. 1 times negative I, negative I. Negative I times negative 1, positive I. Negative I times negative I, positive I squared. So that would give me negative 1. Oh, negative I and I would cancel, and then I squared is negative 1, so that give me a solid negative 2. Right? Now, we haven't talked about, or maybe we did, and my mind's getting confused in a lot of classes I teach, but this is actually we'll come back to that later. I don't want to throw you off. Anyways, okay, so 2 plus negative 2 is 0, and then 1 minus I times 0 is 0, and then 0 plus 0 is 0, and then 1 minus I times 0 is 0. So again, so that times that is 0. 0 plus 0 is 0. 0 times that is 0. Now we have 4 plus 0 is 4. 4 times 1 minus I, you would distribute that out. So that would be 4 minus 4I. So 4 times 1, 4 times negative I. And then we get negative 8, and we combine it with this one. So negative 8 will only combine with negative 4. So that'd give me negative 4 minus 4I. Right? Now we take this and we have to distribute that one. So let's do a different color so we can see our next word. So this would be 1 minus I times negative 4 minus 4I. Here we go. So 1 times negative 4, negative 4. 1 times negative 4I, negative 4I. Negative I times negative 4, positive 4I. Negative I times negative 4I would be a positive 4I squared. This would cancel with this. Then I get negative 4. I squared is really a negative 1. So I end up with negative 4 minus 4, which is negative 8. So then here's my result here. And then 8 plus negative 8 is 0. So now, to write this answer beforehand, the question was, oh, okay, well, 1 minus I, or x minus 1 plus I, is a factor of this function, or 1 minus I is a 0 of this function. But the question was to write the answer as q of x plus r of x over d of x. Well, here is some interesting stuff. This right here is your q of x. All right. Now, to write it out with all the correct variables, you must decrease a degree. So this right here would represent my x to the fifth. So that becomes 1x to the fifth. And then this becomes, I'm going to put a plus sign there, x to the fourth, x to the third, so plus x to the second, plus x, and then plus, this will be my constant. So to write this out a little bit cleaner, this will become x to the fifth plus -1 minus I times x to the fourth. I don't need a cube. I don't need a square. Plus 4x plus -4 minus 4i. Now it says plus rx over dx. This means I have no remainder. So I will not have an rx over dx. And then this right here itself would be the answer. So instead of doing that long division to get that answer, I can use synthetic division to do this as long as it's in that form. If it's not in that form, like we did on example 3, synthetic division will not work. All right, let's do this a couple more times to make sure we got it down. We're going to look at example 51. Right? Your homework is really liking the eyes, so I wanted to make sure I gave you plenty of examples for that. All right, so we have 2x cubed minus 10ix squared plus 5x plus 8 minus 3i divided by x minus 3i. All right, so let's do some pre-work. So we take x minus 3i, set that equal to 0, so x equals 3i. So 3i would go into the window. And now I'm going to write all my coefficients. So x cubed would be 2, x squared would be -10i, x would be 5, and my constant would be 8 minus 3i. I have no missing terms, so I didn't have to fill in any zeros. Start the process by not forgetting to drop down the first number, and then repeat the pattern. 3i times 2, 6i. Now so I can multiply, then add. -10i plus 6i is -4i. 3i times -4i. I'm going to do some pre-work over here. It's not going to be as much as what we've been doing. But this will be 3i times -4i. So that would give me -12i squared. And then I know that's -12 times -1, which gives you a +12. 5 plus 12 is 17. So now I'm going to do the same thing. 3i times 17. What's that? 30, 51. So that should give you 51i. Okay. Hold on. Did I move a number wrong earlier? Okay. My brain just went somewhere else. All right. Hopefully that's 51. All right. And then to combine like terms, this will just be 8 plus 48i. Because that right there would just go down by 3. Again, that would be my remainder. So again, this would be my x squared plus x plus my constant. Again, I like to clean it up. So it's going to be 2x squared minus 4ix plus 17 plus 8 plus 48i. That's your remainder. That's your r of x. Divide it by what you were dividing by, which is x minus 3i. Yep, and there you go. And so that would be an example with an Rx and a Qx, or an Rx over a Dx with the Qx. All right. All right, let's do just one more before I move on to the next part, which is a little bit more, in my opinion. Example 52. Maybe it's not. To me, maybe. I just want to make sure you are prepared. All right, so number 52, 4x to the fifth minus 6x to the fourth plus 10x cubed minus 4x squared minus 4x. all divided by x minus 1. So 4x to the fifth minus 6x to the fourth plus 10x cubed minus 4x squared minus 4x. All right. So again, we're wanting to still use synthetic, and I can because it's in the form of x minus c. So a little pre-work. X minus 1 equals 0, so therefore x equals 1. 1 is what goes in here. So this should be nice, nice clean. So this is x to the fifth will be 4. X to the fourth is a negative 6. X cubed is a 10. X squared is a negative 4. X is a negative 4. And I don't have a constant, but I am going to put a 0 there for that term. Drop down that first number and get the party going. 1 times 4 is 4. Negative 6 plus 4 is negative 2. 1 times negative 2 is negative 2. 10 plus negative 2 is 8. 1 times 8 is 8. Negative 4 plus 8 is 4. 1 times 4 is 4. Negative 4 plus 4 is 0. 1 times 0 is 0. 0 plus 0 is 0. And that is my remainder. So therefore, to write this out, this would be 4x to the fourth plus negative 2x to the third plus 8x to the second plus x plus 0. So to clean it up, this is 4x to the fourth minus 2x cubed plus 8x squared plus 4x. There was no remainder, so it came out perfectly even. Right? So there's the last example for that one. Let's move on to the last part of the questions you're going to get, which is a little like going backwards. So beforehand, you were trying to find this. Now I'm going to give you information so that you can give me what the polynomial function is. So this is what I mean. So let's look at example 53. You're asked to construct a polynomial function with the stated properties. You are told it has a second degree. So that means that I have two answers, and it gives you the two answers. The zeros are negative 4 and 3. So zeros, so it's a second degree. And the zeros are equal to negative 4 and 3. And then it does give you a little bit more. N goes to, basically as x goes to negative infinity, f of x goes to negative infinity. All right, so it says it weird because it says goes to negative infinity as x goes to negative infinity. So that's that missing part, that f of x there. All right, I'm actually going to ignore all of these facts right now, the second degree and all of this, and we'll bring that in if need be at the end. But what I know is if these are zeros, these are like my C values, then the factor, remember the factors, I wrote this down the very first slide. If C is a 0, then the factor is x minus C, which basically means if C is a factor, I can change the sign and now I have my factor. So if negative 4 is a 0, x plus 4 is a factor. If 3 is a 0, x minus 3 is a factor. So what I'm going to do before I get into these two terms here, I'm just going to focus on this. So I'm going to FOIL or distribute this out. So x times x, x squared. X times negative 3, negative 3x squared. Where am I at? 4 times x, 4x. 4 times negative 3, negative 12. Combine like terms, I get x squared plus x minus 12. All right, there we go. All right, so this would be true and just be done with that. But then we have to bring in these next terms. Here's my zeros, checked. It has a second degree as the highest exponent, check. But then is this part true? So as x goes to the left, does y go to the right? So what you have to know is, all right, so it's a second degree, so that means it's even, right? So that means it's going to be a parabola shape. But if my y value is going down, that means I must be doing this because they either both go up or they both go down. What will cause that to go down, my coefficient must be my leading coefficient must be a negative. So what I have to do is just multiply by -1 to the entire function. So that gives me negative x squared minus x plus 12. And there's your polynomial function. It has those as my zeros. It has the leading coefficient having it go down, and it's a second degree. Right? Let's do a few more to make sure we have this part down. So let's look at example 54. This one says it's a third degree, has zeros of -2, 1, and 3. And it also adds in the y-intercept is -12. Just so you are aware, the y-intercept is always the constant. So -12 should be my last number when I do this work. All right, but let's start with just the zeros. So this is going to be x plus 2, because we just x minus c, that'll just change the sign. X minus 1, x minus 3. Now let's get into some distributing. X times x, x squared. X times -1, -x. 2 times x, 2x. 2 times -1, -2. Combine like terms, so I get x squared plus x minus 2. And now let's distribute again. So x squared times x cubed. X squared times -3, -3x squared. X times x squared. X times -3, that's a plus, by the way. -3x. -2 times x, -2x. -2 times -3 plus 6. One thing I always get to, it doesn't matter which direction you distribute. I distribute all 3 terms into the 2 terms, but you can take all 2 terms and distribute into the 3 term if you would like. But then you still have to combine like terms, and you would still get to the same conclusion. So this would be x cubed minus 2x squared minus 5x plus 6. All right. So this is things we got to work on. So we have 3 terms, 3 degrees. So these 2 things are checked off, but the y-intercept is what's throwing us off. So basically what you have to do is ask yourself, what do I have to multiply to 6 to give me -12? And hopefully you're saying, well, just multiply by -2. So that's what we're going to do. We're going to multiply by -2 to everything. So that's going to give me -2x cubed plus 4x squared plus 10x minus 12. I still got my third degree. These are still the zeros. That's how I got to this point. And then now the y-intercept, which is the constant term, is now a -12. And so therefore, I now have the polynomial function that has those 3 things. All right, let's do 3 more. Let's look at example 56. This time, you're told it's a third degree. You're told the zeros are 1 minus I. Told you they like the i's in this one. 2 plus I, and -1. All right, so that's going to take care of that third degree as well. And it does say our leading coefficient will be a -2. So that will come in at the end. This is usually taken care of by the zeros, and we take care of that last part at the end. So if these are my zeros, then technically my factors would be x minus 1 minus I. So notice this is my C, it's just an I, okay? So then this is x minus 2 plus I, and then this would just be x plus 1. So I'm going to go ahead and distribute this out. So this gives you x minus 1 plus I, x minus 2 minus I, and then x plus 1. All right, so there are a couple of ways to go about doing this, and I find this way to be easier. You could have taken 1 minus I and distribute that as well. I'm just going to turn them into 3 terms and then kind of work it that way. All right, so here we go. So x times x squared. X times -2, -2x. X times -I, -ix. -1 times x, -x. -1 times -2 is +2. -1 times -x, positive I. I times x, positive ix. I times -2, negative 2i. I times negative I would be negative I squared. All right. So it can definitely get confusing. So make sure you follow along with however you do the work. But a 3 term times a 3 term, I better have 9 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I do, so that tells me I didn't miss anything. Now I'm just going to combine like terms because I have to do this x plus 1. So I get x squared. I get a negative 2x, a minus x. So that's going to give me a negative 3x. What I like to do too is I'll cross out once I've done it. I see a negative ix and a negative ix, so that looks like that cancels. And then it looks like an I and negative I. That's almost like a number, but I'll write it anyways. So that's going to be a negative I. And then this right here, this I squared, I'm just going to go ahead and rewrite it as a negative 1. So I see that it's actually a plus 1. So I'll get rid of it again. And 2 plus 1 gives me 3. Is that the, well, I guess I have to finish the problem. But we'll keep going. So now I'm going to do this. I think that's as clean as I could get it. So now let's distribute again. So x squared times x is x cubed. X squared times 1, x squared. Negative 3x times x, negative 3x squared. Negative 3x times 1, negative 3x. Negative I times x is negative ix. Negative I times 1 is negative I. 3 times x is 3x. And 3 times 1 is 3. Okay, I can combine a little bit. So x cubed, this right here would become negative 2x squared. Looks like the x's here would cancel. And looks like I then have negative ix minus I plus 3. And then it says the leading coefficient needs to be a negative 2. So the very last thing I'm going to do is just multiply by negative 2. So this gives me negative 2x cubed plus 4x squared plus 2ix plus 2I minus 6. All righty. Let's see how far off we were. Looks like we were dead on perfect. Oh, the only thing, because this right here is technically your constant, and we always have to write it as a plus bi. So if they count this wrong in your homework, it's because they want it to look like this. So it's almost the same thing, but it'd be minus 6 plus 2i, so that it goes a plus bi format. All right, so that was a good one. Let's do a couple more. Then I'll feel more confident that you're pretty good. Let's look at number 57. All right, 57 says fourth degree and a single x-intercept of 3. So I told y'all at the beginning of this, or maybe it was yesterday, or the last video, sorry. In the last video, that 0 solutions, x-intercepts, and roots are all the same meaning. So if I tell you the x-intercept is 3, I'm telling you the 0 is also 3. And if 3 is a 0, then that means that x minus 3 is a factor. Now, this is all the information we give us, but then we're told it's a fourth degree. So that means that if this is my only answer, this is going to become x minus 3 to the fourth. So I also told y'all that if whatever the degree is, that's how many answers you're going to get. So if it's a fourth degree, I better have 4 answers. They just so happen to be the exact same answer. So I would have got 3 4 times. All right, so here we go. So with that, I have to do a lot of work. So x minus 3 times x minus 3 times x minus 3 times x minus 3. So let's get into it. So if I multiply this, I'm going to actually use this terminology. a minus b squared gives me a squared minus 2ab plus b squared, just to kind of speed up the process. So this right here, this x minus 3 times x minus 3 is the same thing as x minus 3 squared. So this is just going to be x squared. Here's my AB, so that's going to be negative 3x times 2, which gives me negative 6x. Negative 3 squared would be positive 9. And then this would be the exact same thing. Now, if you didn't quite follow, by all means, distribute it out, combine like terms, and then you'll see you'll get to this conclusion. Now I'm ready to just move on to the next step. So x squared times x squared, x to the fourth. X squared times negative 6 is going to be negative 6x cubed. Then 9x squared, negative 6x cubed, positive 36x squared, negative 54x plus 9x squared minus 54x plus 81. All right, to combine like terms, we say x to the fourth, that goes away. I have negative 6x cubed, negative 12x cubed. I have 936, that looks like that, or 918. Maybe it's easier. 9 plus 36 would be 45. 45 plus 9 would be 54. So we'll say plus 54x squared. That would give me negative 108x and then plus 81. And there you go. So when you have something like that, that's the process you go. All right, last question, and I'll conclude today's lesson. So in example 60, it says it's a third degree. The zeros are 1, 2, and 3, and it passes through the points 4, 12. All right, so we'll come to that concept here in a little bit. All right, so to do this, this is going to be x minus 1, x minus 2, x minus 3. So let's get right into it. Again, just to kind of speed through this process, this would be x squared minus 3x plus 2, x minus 3. And then this would be x cubed minus 3x squared minus 3x squared plus 9x plus 2x minus 6. All I did was do the whole distributing without all the lines. And then this gives me x cubed minus 6x squared plus 11x minus 6. But then we have this point right here. And the issue with this one is we have to ask ourselves, all right, if I plug in a 4, will I get a 12? Okay, so let's do some side work here. So I'm going to plug in 4 cubed minus 6 times 4 squared plus 11 times 4 minus 6. So this will give me 4, 16, 64. That's going to be 16 times 6. That's going to be, see, 6 times 10 is 60, 96. That'd be just 44 minus 6. All right, so let's kind of do some math. I don't want to make a mistake. All right, hold on. So let's do this. This will be 64 minus 96 plus 44 minus 6. And that just give me 6. All right, so since I only got 6 out of it, I could technically take this entire thing and multiply it by 2, and then I would get 12. So that's all I had to do is determine, all right, if I plug in 4 and I got to 6, what do I need to do to get to 12? Well, if I multiply the entire thing, so it's not going to adjust any of the math. It's just like as if I took the 2 and I did it at the very last second. So what I'm going to do then is just take this, multiply by 2. So this gives you 2x cubed minus 12x squared plus 22x minus 12. And there's your answer. Again, as always, if there's more examples you would like me to go through or need any help, please reach out. Until the next video.